Hi everyone, welcome to this session in which I'll be walking you through the Excel implementation of the Vasicek interest rate model. So what we are trying to do is first in this video, we'll be trying to understand or we'll try to calculate the parameters of the Vasicek interest rate model. If you have not seen my first video, which focuses on the theoretical understanding of Vasicek, I really encourage you to watch that. And then in this video, I'll be basically walking you through the Excel implementation. See, for building any interest rate model, right, it is very important to get the historical data. So what I've done is I have got the data of interest rates for 2024 and 2023. The website that I have used is treasury.gov. So basically in the treasury.gov, you will get all the, basically the curve data, which is the yield curve data for all different dates. Now, in the video, in the Vasicek video, the first video I was telling that, the rates are stochastic, the rates are random. But what does it really mean, like how rates can change now? So let's say because in this video, we'll be basically forecasting the 3-month interest rate, right? So now if you see every day the rates are changing by some amount, the rates are changing by some amount. And that's why we need a model or a mathematical model which can actually help us, evaluate this or, which can help us build a model which can, which can help us forecast this interest rates, right? So that's why as I said, these interest rates are not constant, and that's why we need a stochastic interest rate model which can be used to forecast the interest rates. So in this video or in this Excel implementation, what I'll be forecasting is the 3-month interest rates. Okay. So let me walk you through this the Excel implementation. So see, this is the Vasicek interest rate model that you see on your screen. But let me tell you, how did I build this model? So what I did was, when I started building this model, right? I mean, I had the data from, March, April, May. So this is June 3rd, 2024, and I almost took like a 1 year data. So if you see, there are 252 data points, right? So I just considered last 1 year data, and this data is nothing but the 3-month data. As I was saying earlier also, let's say if you see the sixth, if you see, we are trying to forecast the interest rate for 3 months, so we are trying to focus the 3-month interest rate. So I've, basically taken the values of the 3-month using these two tabs. So you can basically get this whole data from this link, which is the treasury.gov. But let's assume that we have got this 1 year data, right? So what is the next step? Now, if you see this data, we need to process it first. So first we need to make sure it is in numbers. So that's why I've divided. So this 5.52 is in percentage. So I just divided it by 100 to get this interest rate in numbers. Um, so what is the next step, right? So the next step is, okay, so just give me one second. Let me, okay. Yeah. So let me delete. Okay. So as I said, if you remember this equation, this Vasicek equation on this, which you see on your screen, right? DRT is equal to A times B minus RT dt plus sigma dWt. Now, what is this DRT? DRT is nothing but the change in interest rate, right? So let's 0, 1, 2. These are 3 different days, right? So what is, so let's say this is, we have this R1, R2, right? So DR is nothing but the difference between, the difference between R1 minus R2 minus R. So it's nothing but the difference between the changes in interest rate. So if you see, what I've done is I have just calculated the change in interest rate. So this term, right? RT minus 1, right? This is nothing but our DRT term, which is the change in interest rate. And that's why I'm saying, if you have not seen my theoretical video on Vasicek, I highly recommend that, because in that I have explained what is all the terms in this used in this Vasicek equation. So as I said, DRT is nothing but the change in interest rate. How can we find the change in interest rate? Is what is the interest rate today subtracted by what was the interest rate yesterday. So like this, I have actually, calculated for the whole 1 year what are the changes in interest rates. Okay, so let's see. So these are the changes in interest rate that is happening over the time period, right? So now this is how I have implemented my Vasicek equation. So as I said, this the idea, first thing that we do is we estimate the parameters of the Vasicek interest rate model, right? So to estimate the parameters, the process that we are following is maximum likelihood estimator. So what we are essentially doing is we have calculated the actual change, the actual DRT, right? So so this actual data is from the market, from the market, and that's why we have calculated the actual change in rates. Now using the Vasicek model, we are again trying to find what is the change in rates. So as we all know, this is the equation of Vasicek. So let me walk you through what are the terms here. So let's say this A term is nothing but your mean reverting speed, B is nothing but your long-term mean, sigma is nothing but your volatility. So these are the three important terms which we will be using in our Vasicek model, right? So if you see this this is nothing but A, which is our long-term mean. This O2 is nothing but our B, which is our sorry, A is nothing but our mean reverting speed of mean reversion, right? A is nothing but a speed of mean reversion. O2 is nothing but our B term, which is the long-term mean. Now RT, so the equation is A times B minus RT. Now this RT is actually RT minus 1, So this is basically the previous interest rate. So let's say if we are trying to model today, so this RT is nothing but yesterday's interest rate. Okay. So A times B minus RT dt, right? DT is nothing but your change in time. We all know that the change in time, let's say if we have we all know that can we calculate the change in time, because we are trying to predict the interest rates every day. So 1 divided by 252 is nothing but, the change in time. So dt, which will remain constant, right? Which is nothing but 1 divided by total number of days that we have. So dt is nothing but 0.00396. And dt will always remain constant. Why? Because we know that we have 252 days and we are trying to model every day. So coming back to our equation, A times B minus RT, O6 is nothing but our DT term, right? And plus O3 plus sigma, sigma. Again, this is the Wiener process. And as I said in the last video, how can we define a Wiener process is, square root of time multiplied by the random variable, which has been generated using the normal distribution. So square root of time is nothing but square root of O6, which is our dt, right? And this norm dot s dot inverse random, this is nothing but we are trying to say we are generating a random number from a normal distribution, and this is what makes our equation stochastic, or this is what makes our equation random, right? So this is the DRV. This is the change in interest rate using the Vasicek model. So like this, we'll basically try to calculate the change in interest rates using the model for the last 252 days. So we have calculated this actual change in interest rates, and using the Vasicek model, we have calculated the modeled change in interest rates. The interest rate that is coming through the model. Now, see, this is the change in if you see this equation, this is nothing but the change in the interest rate. So let's say if we want to find what is the interest rate, so what we will be doing is nothing but will just use this change in interest rate plus, which is coming out of the model, plus the yesterday's interest rate. So this will give us today's interest rate. Okay. So what it is saying is, now if you see all these previous interest rates, right, it was 5.46, and you saw suddenly there was a jump, but because this jump was not expected by the model, that's why it predicted 5.46. But if you see, this whole graph, the model and the actual is very close. But I'll tell you how it's so close, because I have already done a calibration of parametric estimation of this model using MLE. So but if you see, our model was how will we find the interest rate as of today? So we'll basically get the modeled interest rate, which is basically the change in interest rate using the Vasicek model, and then we will add the previous day interest rate to calculate today's interest rate. Okay. So after we found this, what we are trying to do is, so this was, this I calculated y just so as to compare what is the, what is being generated by the model and what is the actual data. So that's why I've calculated this. But let's say, how can we use the MLE method, which is the maximum likelihood method, to derive or to get the parameters of the Vasicek model is, first, as I said, we will be finding the difference between the actual data and the modeled interest rate. So we'll basically calculate the difference between the actual interest rates and the model interest rate, right? So once you do the difference between the actual and the model, the next step is to take log transformation. Sorry, the next step is to take normal distribution. So why we are taking normal distribution? Basically, what we are saying is, all this residuals, or you can say all this numbers, right? The difference between the actual and the model data, or the actual and the model interest rate. What we are saying is, if you see this whole formula, right, we are saying that, okay, this x is nothing but the difference between the two, and make this value, the mean of it, make it 0. So that's what we are saying. Make this value 0, okay? So that the difference between the two is actually 0. And what is the standard deviation? So this I have taken some arbitrary number, right? In the beginning, I've taken some certain arbitrary number, and then in the end, cumulative. No, we are not taking any cumulative distribution, so it will be false. So that's how you calculate the, what we are saying is, this thing should follow normal distribution with a mean of 0. So basically what we are trying to do is, we are making all these values very close to 0. Now what is the next thing? So the next thing after you do this is, see, if you see, MLE is nothing but you are maximizing the likelihood of a estimator, right? So how you do that is by, you have to multiply these numbers to find out the sum of the ML, to find out this sum. If you see, to find out this sum, you'll have to multiply these numbers. But this, if you multiply these numbers, this acts, I mean, just imagine, if you multiply this, assume right now it's 0, but assuming this is some number, which is not 0. But so if you multiply all these numbers, I mean, I mean, it will become such a computational intensive job, right? Because all these numbers are like 4 digit, and you need to multiply all the 252 data points. So this whole task will become really computational intensive. So that's why what we are doing is, we are just taking the log transformation of this. So what happens when we take a log of, so if you see something like a times b times c, right? And when we take log of this, log of, let's say, this number, a times b times c, what will happen is, it will become nothing but log of a, sorry, a plus log of b, plus log of c. That's it. So that's why we are taking the log. Okay. So now we have taken the log of it. And then what we are doing is, we are just summing it up, so that we can maximize this likelihood function. After you sum this up, the next step is nothing but, you need to go to data, right? You need to go to the solver, and then what you do is set this objective function. You say this sum, this sum is should be maximize this to 0. Okay. Maximize this sum, which is L2, to 0. How? By changing which variables? These three variables, which is a, b, and sigma. And once you do it, let's say once you click on solve, keep solver solution, okay, it will give certain value. So so it will give this value, right? Now, because it has given this value, so if you see, when you actually plot, initially what you can do is, you can take some constant, any arbitrary number. Let's say something like, you can take 0.5 for a, b, and sigma. Okay, that's what I did. I just took any some arbitrary number for a, b, and sigma, and then what I did was, I used this solver, and then basically set this, let's say set this L2 to maximize this value, right, to 0. And by how? By changing these three variable. Let's say 0.5. Let's say assuming these three variables are 0.5, and then just say solve. That's it. Okay. Yeah, just say solve, and that's it. So So that's how you will get the values of A, B, and sigma in your model, right? And now if I just, if I just plot this Vasicek model with the actual data, see, if you see, this is so close, which basically means that yes, our model, the calibration has, it's really good. And we were able to calibrate the Vasicek interest rate model, or we were able to find the parameters of the Vasicek interest rate model using the maximum likelihood estimator. So any doubt, guys? Any doubts up till now? Okay, so I'll take that as no if there are no doubts. So the next part is simulation. Okay, see, what happens is we need to use, once you calculate these values, right? Once you have calibrated your model, you know, um, okay, so something wrong, but these were my calibrated values. So let's say, let me use these. Okay, these were my calibrated values. So so what happens is when I use my calibrated values in my simulation, let's say this part, right? So if you see, we now the next goal is to do simulation. See, now we have already estimated our parameters of this model, right, which is A, B, and sigma. Now the next step is to forecast the interest rate. So for forecasting the interest rate, I'm forecasting it to next 1 year. You might be thinking 1 year and it has 253 data points and not 252. Why is this? Because you remember 2024 is a leap year. So leap year has a day extra than the normal year, right? And that's why we have 253 data points. So now how am I simulating these interest rates, right? So let's say, if you all remember, basically this was my interest rate, actual interest rate, which was 5.52 on this date. Okay. So let's say 5.52 was my interest rate on day 0, and I'm trying to predict the interest rate for the next 1 year, right? And here we'll use the concept of Monte Carlo simulation. If you guys remember, I told you, right, that we need to discretize our equation, right? So that's how we'll be using this Vasicek, and we'll be using that into our simulations of Vasicek. So now how can I use the same equation, which is this Vasicek, this equation, into for our simulation purposes? See, because Excel, I cannot do like 1,000 or 10,000 simulations in Excel. It will take forever for me. So that I just want to demonstrate the concepts to you, like how this model is been estimated using MLE, and then once it's estimated, how to forecast the interest rates the using the Vasicek interest rate model. So what I right now I'm doing is 10 simulations, but in real world, what you do is really large number of simulations, 1,000, 10,000 simulations, depending on what is your financial instrument. So this, as I said, on day 0, our interest rate is nothing but 5.52%, which was this. What we are saying is we are trying to find the interest rate for next 1 year, right? So this is our day 0, 6/3/2024. This is basically June 3rd, sorry, 3rd June 2024. So these are set as of US format, but so this is the month, this is the date, and this is the year. So June 3rd, 2024. Okay. So moving on to the simulation, right? So how to perform the simulation? See, it's as simple. We just need to use the same equation. See, once our model has been calibrated, we just need to use A times B minus RT dt plus uh, sigma, square root of time times our random variable. And then in the end, what we need, because this part is nothing but our DRT term, right? Change in interest rate. So you need to add the change in interest rate with the previous interest rate, right? So this will give us the whole Vasicek interest rate, right? So if you see this, this was our interest rate 5.52. So what I did was A, which is our, which is our speed, mean reverting speed, A times B, which is our long-term mean, B minus RT. So RT is what? The previous interest rate. As I said, remember guys, RT, please remember here it is RT, right? But it is actually the previous interest rates. So A times B minus RT dt. Dt is, as I said, the time will remain constant. You know, if I move today, tomorrow, day after tomorrow, the change in time, dt, so the change in time is nothing but 1 day. So 1 divided by 252 is our dt term. Okay. So A times B minus RT dt plus sigma. B3 is nothing but a sigma term. Sigma times square root of dt and times this random variable which is generated using the normal distribution. So this is how, this is our DRT term, and then we are adding what? The previous interest rate. So if you see, we are adding this interest rate to find what is the interest rate on day 1 of our simulation. So now how to find the interest rate on day 2? It is the same equation, only the factors that will be changing is our e. So if you see, this is let me show. So this is the interest rate is the only thing, this RT term, right? This is the only thing that will change. Otherwise, A will remain constant, B will remain constant, our DT will remain constant, sigma will remain constant, and in the DWT term, which is DWT is nothing but this term, right? This will dt will remain constant. This is a random value which ensures our randomness in the process, and E3 is nothing but our previous interest rate. So this is how we'll simulate the interest rate on day 2. Similarly, if you see the last day, right? Similarly, if you see this is nothing but we are taking yesterday's, we are using the same equations. Only thing that will change is the interest rate. So if you see here, E of RT term, this RT term will change, which is nothing but yesterday's interest rate. And then we'll again add the yesterday's interest rate in the whole process. So this is how you will be simulating your interest rate using the Vasicek interest rate model. So this is one simulation. Like this, you do multiple simulation, and see, if you see, this graph is changing. Why is it changing? Because this specific, this term, norm dot inverse, let me get this term out. Okay. So so if you see this term, right? So this is nothing but we are generating a random variable from a normal distribution. So this will, as we, click, or as we refresh our data, it will always change. And that is what we actually want, right? We actually want to include the randomness in the model. Why? Because interest rates are not straight. Interest rate actually fluctuates. How? Because if you see here, these interest rates are fluctuating, right? It is not the same. Sometimes it's 5.31, 5.33, 3.4, 3.2, right? So that's why in the simulations, this whole this is not, this thing is capturing this whole randomness in the process. So let me delete this. So that's how, this is how one simulation and is done. You will perform like this. You will be performing many other simulations. So close to, sometimes people do 1,000, 10,000 simulation depending on what financial instrument. But because Excel, it is not possible for me to do like 10,000 simulation in Excel, because it will take forever. So just for a concept illustrative purpose, I have done the simulation using only 10. I have done only 10 simulations, but the concept will remain just the same. We'll use the same parameters, and the only thing that will change is the interest rate, right? As I said, this RT term, which is nothing but the previous interest rate, that is the only thing that will change. So this was all about this Vasicek, how to simulate the interest rate using the Vasicek interest rate model. Any doubt, guys, up till now? Okay. So maybe I'll take that as no. In the next video, what I'll be showing you is how to use this Vasicek interest rate model to price caps interest rate derivatives. So the two interest rate derivatives which we'll be focusing on is interest rate caps and interest rate floors. So I'll be telling you how can we use this Vasicek interest rate model to to calculate the price of interest rate caps and interest rate floors Also, one more thing which I want to highlight is there's one more model which is called the Black 76 model, which can be also used to price interest rate caps and floors. But as I said, you can solve any stochastic model using different methods. So this Black 76 model, was actually solved using the analytical method. Okay. And what we are trying to do is we are trying to use the Monte Carlo method, okay, to solve this Vasicek interest rate model. So these are different approaches, but yeah, the idea remains the same. That is, we are trying to forecast the interest rates. So that was all for this video. Are there any last doubts as of now? Okay. So as I said, this is a complete end-to-end project. So the first part of the video was to understand the theoretical understanding of Vasicek. In this video, I gave you our Excel implementation. In the next video, I'll be basically explaining you what is interest rate caps, interest rate floors, and how can we use Vasicek model to compute or to value interest rate caps and floor. And then in the next video, I'll be basically walking you through the Excel implementation. So again, this is a end-to-end project, and I hope you understand this. So I'm just stopping the session. Thank you so much for joining in.